my name is Rich Howard, owner of Architectural Builders Supply, and this video is to attempt to replicate a door pull that a client sent to us. I saw the photos and I immediately realized, well, this is going to be 1960s, would be my best guess in terms of a vintage. Okay, so we're going to put the dust boot on and just let this keep rolling. Just making sure the spindle's off. Yeah, I'm satisfied that we're shooting the air where it needs to go. I'll tell you, what I'm going to do is probably do maybe a 100,000th depth on either side of this profile cut, here and here, just 100,000, so that my V-bit is not making contact here or here. That'll be the plan. Growing in the wrong direction.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
We're going in the right direction. My mistake was, I was thinking about the quality of the cut on the outside. I don't care about that. I don't care about that. I care about that. So we were going in the right direction.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Okay, we're down to it here, and I'll tell you, everything's looking pretty good. That chattering is certainly the end mill hitting the balance of the aluminum. Aluminum is tenacious. It doesn't, aluminum it'll move before it lets go. When you're pushing down on the end mill, it'll push the aluminum down. So you've really got to go through aluminum to get it to cut. But we're 10 thousandths deeper than our material thickness, and there's a little bit of aluminum left. Hopefully we'll hear that chattering. What's left there would just peel off, that's for sure. And I think we're in our final pass. So let's look at our depth on ShopBot. Yeah, that's our final depth. So we're done now. Yeah, okay, it's good. This I don't like. Dust collection is off. What's left here, that's just going to come right off. You can see the little black marks right at the corner. That tells me that we've gotten through it. So we've done our profile cut, and now what's next is, I'll tell you what's next. I'm going to do an additional vector that's going to be, this is 1 7/8. And we're going to go to the outside of that line, and we're just going to go down about 1/8 of an inch. Just because I don't want that V-bit to make contact over on that side. Once that's done, we're then going to put the V-bit and profile both sides. Vectric has responded to me because when I have an open vector, I have an open vector, and for this example, I want to go down 0.25. But I don't want my V-bit doing this because of your climb versus conventional cut. On one pass, I get a gorgeous finished edge, and on the other, when it's going this way, I get a great finished edge. When it's going this way, I get an awful finished edge if it's the outside edge. Doesn't matter, you'll see it. I want it to pick up, increase the depth, pick up, increase the depth, pick up. That's what I want. So it's going to be a matter of getting into that. And if I don't get it solved in order to get this workpiece off the machine, I'm just going to go back and forth, and then I'll make one final finishing pass and be done with it. Now, here's a little sneak peek of the next job. Here's the next job. I've got this framing that's on the table. As I've said 100 times, this is an 8x4 tool. I've got some framing here where I'll be able to take a much longer piece and get it onto the machine and let it hang long. This job is 1/8 inch aluminum, and it's just threshold plates is all it is. So it's just a profile cut in a chamfer, not even a bevel. And these are the sheets of 1/8 inch aluminum. Now, why 12 foot? Because it's cheaper to buy 12 foot. At least I think it is. We're going to have to play with that, because when the mill is doing the cutting, it just simply costs more. So I say, you know what? I've got this fancy ShopBot tool. Why not let it do the cutting? Meaning, I'm going to put the 12-foot sheet on there, and I'm going to do my work down in this area here, because I want to be able to achieve the maximum lengths possible and just yield as much as possible without turning this entire warehouse into just a storage facility of drops or cut off pieces of aluminum. But the material is super valuable, it's super expensive, and I do have a small collection of drops, so to speak, and let me show it to you. Obviously, this is what's left. This is one piece left over from our hand wheel project, as is this piece. This piece has, I still have to do machining on this piece. Then I've got some odds and ends here, and I had mentioned that I still had a piece of 1-inch aluminum, and I do. It's right there. So tomorrow we're going to pick up with doing that profile to relieve ourselves of our profile, our bevel bit. We'll figure out what's going on. If I can get that, pick up. If I can't, we know what we'll do. We'll master it at some point. And we'll just keep going. Thank you very much for your continued watching.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
So here we are the next morning, and we're going to pick up where we left off. So I'm going to work on the open vector, how to pick up and then go deeper, then pick up and then go deeper. But really, what I'm going to do right now is I'm just going to create a rectangular closed vector, and I'm going to take that 120-degree bit, and I'm just going to go along it, is what I'm going to do. And I don't want to bevel the outside ends, so what I'm going to do is when I first run my shallow pocket relief so that I'm beveling on one side of the piece only and not unintentionally beveling the piece, not the door pull. I'm just going to run it a little bit longer so that my 120 doesn't get into that at all. And we'll switch to the screen view now, and we'll take a closer look at what that dimension should be so I know how big of a vector to make. It'll be clear as we go along. Let's move forward. So what I mean by that, we're going to bevel this side, but I don't want to get into touching this side. So we're going to make a small, shallow, 1/4 inch wide will be adequate, I believe, a shallow sort of profile here, so that my bit is only beveling the workpiece, not the remainder. So let's switch over to V-carve and get an idea, and we are going to be doing a 120-degree bit. Actually, let me make sure I've got that bit before I just jump in and proceed. Yeah, I have this 120-degree bit. The 140 is what I use when I'm doing threshold work because of its rise over run compatibility. Why? Well, when I measured the client's existing pull, that's kind of what I came up with. The relation, you know, A squared plus B squared equals C squared. This gave me this. And 120 was really, really close. And you can see what we're replicating. You get the idea that this is a pair of doors, so that's why I'm going to prototype our mounting brackets a little bit better, because I'm matching one. It's going to be right next to it. So yeah, we want to get that as best as possible. Okay, so we are good with the 120. I've got it in my hand. Now, let's hop back over to our software.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.